Hi everyone, this is Srikanth, Assistant Professor of EEE Department. In this session, I am going to discuss some problems on Thevenin's theorem. Here it is the problem given. We need to calculate the Thevenin equivalent between A and B terminals. We need to calculate Thevenin equivalent between A and B terminals. For Thevenin's theorem states that any linear bilateral circuit can be replaced with a single voltage source in series with the resistance, where voltage source is the open circuit voltage across the two terminals, and equivalent Thevenin resistance is the equivalent resistance between the two terminals by making the other sources to non-operative. That means voltage source is replaced with short circuit, current source is replaced with open circuit. So here first let us calculate the VTH. Here VTH calculation. For that I am making the RL open circuit. I am making the load resistance as open circuit. So here 3 ohms, 6 ohms, 9 volts, and here we need to calculate the open circuit voltage. So here this open circuit voltage, we need to calculate. This open circuit voltage is nothing but voltage across this 6 ohms. That means we need to calculate the voltage across 6 ohms. That is nothing but the open circuit voltage. VOC is equals to V6 ohms. So for calculating V6 ohms, we need to calculate what is the current flowing through 6 ohms into that particular resistance according to Ohm's law. So for that, for calculating I6, here no current is flowing through the open circuit. So whatever the current which is giving, whatever the voltage which is applied, the current will be flowing through only 3 ohms and 6 ohms. Now we can say that this 3 ohms and 6 ohms are in series. So that combination is connected to 9 volt source. So I6 is equals to 9 divided by 6 plus 3, that is equals to 9 by 9, that is equals to 1 ampere. So V6 ohms is equals to I6 into 6, that is equals to 1 into 6 volts. V6 ohms is nothing but VOC, that is equals to VTH, that is equals to V6 ohms, that is 6 volts. Now we got the VTH, and then we need to calculate the RTH. For calculating RTH, we need to make the sources to 0. That means voltage source is replaced with short circuit and current source replaced with open circuit. Here the voltage source is replaced with the short circuit, and the resistance R1, that is 3 ohms. resistance 6 ohms, 3 ohms, 6 ohms, and we need to calculate the RTH. So here the RTH value is equals to, here if you see from these two terminals, 6 ohms and 3 ohms are connected in parallel, because of this short circuit, this 3 ohms and 6 ohms are connected in parallel. So when the 3 ohms and 6 ohms are connected in parallel, the equivalent resistance for parallel resistors is R1 R2 by R1 plus R2. So RTH is equals to 3 into 6 by 3 plus 6, that is equals to 18 by 9, which is equals to 2 ohms. This is the RTH. 3 into 6 by 3 plus 6, that is equals to 18 by 9, and that value is 2 ohms. Now we can replace the original circuit, this original circuit, with a single voltage source. VTH is in series with RTH. That is, here voltage VTH in series with the RTH. It is of the load resistance. This is RTH. The value is 2 ohms and VTH is 6 volts. Now we got the VTH and RTH, and if for any value of load resistance, we can easily calculate the load current by using this Thevenin's theorem. This is the next problem which we need to calculate the Thevenin's equivalent. So here one more resistance is added. So when one more resistance is added, how the voltage and current is going to affect, we are going to see now. So here first, for calculating VTH, we need to open circuit the load resistance. Six ohms, 3 ohms, 4 ohms. This is A and B. So here load resistance is open circuited. Now we need to calculate open circuit voltage VOC, that is nothing but the VThevenin. Here when it is open circuited, is there any current flows through the 4 ohm resistance? No, because in the open circuit no current will flow. So when there is no current, the voltage across 3 ohms, V 3 ohms is equals to VOC, that is equals to VTH. So here VTH is equals to V open circuit, that is equals to V 3 ohms. So V 3 ohms is equals to I 3 ohms into I 3 ohms into 3, that is equals to I 3 ohms. Here in the 4 ohms resistance, no current is flowing. So the 6 ohm resistance is in series with the 3 ohm resistance. So I 3 ohms is equals to 18 by total voltage applied divided by the series connected elements. 18 by 6 plus 3, that is equals to 2 2 amperes, where V3 ohms is equals to 2 into 3, that is equals to 6 volts. Now we got V3 as 6 volts, and this is nothing but the VTH. Now we need to calculate the RTH, where RTH is nothing but the voltage source is replaced with short circuit, and the resistors here 6 ohms, 3 ohms, 4 ohms. Here is the RTH. Here RTH calculation, which is if you see between these two terminals A and B, here this 4 ohms is in series with the parallel combination of 6 and 3 ohms. So RTH is equals to 4 plus 6 is in parallel with 3. That is equals to 4 plus 6 into 3 by 6 plus 3, which is equals to 4 plus 2, which is 6 ohms. This is the RTH. So we got VTH and RTH as 6 volts and 6 ohms. Now our entire circuit can be replaced with a single voltage source in series with the resistance. 6 volts, 6 ohms, and here is the load resistance. We can calculate the load current by connecting different load resistances. Now again we need to calculate. Here a current source is connected. How to calculate the Thevenin's equivalent? Let us see. So here we are having AB terminals. These AB terminals are connected with the load resistance. Now when this load resistance is removed, the circuit will become and this is nothing but the VOC or VTH. Here R1 value is 3.3 kilo ohms. R3 value is 1.2 kilo ohms. And R2 value is 2.4 kilo ohms. And here it is 120 milliamperes. Now we need to calculate the VOC. So for calculating the VTH, first we need to check what is the voltage across which terminal we need to calculate. Here the current is 0. So when the current is 0, so no voltage drop across the 3.3 kilo ohms. So that is nothing but open circuit voltage is nothing but voltage across 1.2 kilo ohms or 2.4 kilo ohms, because both are connected in parallel. So here first let us take the voltage across 1.2 kilo ohms. So current flowing through in 1.2 kilo ohms. So I 1.2 into 1.2 into 10 cube. So for calculating I 1.2, which is equals to, here 1.2 kilo ohms and 2.4 kilo ohms are connected in parallel. When these two are connected in parallel, so the current division will takes place. So source current, which is multiplied with opposite resistance, that is 2.4 kilo ohms divided by 2.4 kilo plus 1.2 kilo, which is equals to 120 into 10 to the power of minus 3 into 2.4 by 2.4 into 10 cube divided by 3.6 into 10 cube, that is equals to 10 cube and 10 cube will get cancelled, that is equals to 80 into 10 to the power of minus 3, that is equals to 80 milliamperes. So this is the current which is flowing through the 1.2 kilo ohms. Now VTH is equals to I 1.2 into 1.2 kilo, that is equals to 80 into 10 to the power of minus 3 into 1.2 into 10 cube, that is equals to 96 volts. This is the VTH. Now we need to calculate the RTH. For calculating RTH, we need to replace the current source with open circuit. Here we are having current source. The current source can be replaced with a open circuit. So and here are the RTH terminals, that is 1.2 kilo ohms, 2.4 kilo ohms, and another resistance is 3.3 kilo ohms. Here, if you see the circuit, this 3.3 kilo ohms is in series with the parallel combination of 1.2 kilo ohms and 2.4 kilo ohms. So RTH is equals to, we can write it as, directly I am writing 3.3 kilo is in series with 1.2 kilo into 2.4 kilo divided by 1.2k plus 2.4k, that is equals to, the value is 4.1 kilo ohms. Hence we got the VTH and RTH. Then we can calculate the load current easily. Now we'll go with the next problem, and here we need to calculate the load current. Here the load resistance value is also mentioned. So we need to calculate the load current by using Thevenin's theorem. So here now let us redraw the circuit by replacing the load resistance with open circuit. So eight volts, 2 ohms, 4 ohms, 6 ohms. We need to calculate the VOC from these two terminals. So here, for calculating the VOC, we need to go with rearranging the circuit. So here I am rearranging the circuit. I am making these two terminals out and 6 ohm resistance to the inner. So the circuit will become like this. Two ohms, 8 volts, 4 ohms, and 6 ohms. This is the VOC. So voltage across 6 ohms we need to calculate. So for that we need to get what is the current flowing through the 6 ohms. So for that I am going with the voltage division rule. I am taking this as the node 1, V1, and here this V1 voltage is applied across 2 ohms and also across a series connected 4 ohms and 6 ohms. So when they are connected in series, so the voltage will be divided. So VOC is equals to 8 into 6 by 6 plus 4, that is equals to 48 by 10, which is 4.8 volts. This is the open circuit voltage and the value we got it is 4.8 volts. Now we need to calculate the Thevenin resistance. For that we need to replace the voltage source with short circuit. Now the circuit will become four ohms, 6 ohms. We need to calculate RAB or RTH, A, B terminals. Here it is. A short circuit is in parallel with 2 ohms. Short circuit resistance is 0 because which is going to have a 0 resistance. When there is a 0 resistance, the equivalent resistance for parallel connected elements will be 0. So our circuit will become only a 6 ohm resistance, 4 ohms, 6 ohms. REAB we need to calculate. Now we can say that REAB is equals to, these two resistors are connected in parallel. That is 6 into 4 by 4 plus 6, that is equals to 2.4 ohms. This is the problem, and now we got the RTH also. Now we got VTH and RTH. Now we need to calculate what is the load current. The load resistance which we have removed is 3 ohms and here it is 2.4 ohms, and VTH we got it as 4.8 volts, where IL is equals to, we need to calculate the IL value. So for that IL is equals to 4.8 by 2.4 plus 3. which is equals to 0.88 amperes. This is the load current calculation by using Thevenin's theorem. Next, we need to calculate the Thevenin's equivalent for this circuit. So here, now for calculating VTH, I am redrawing the circuit. I am replacing the load resistance as open circuit. A, B. VAB we need to calculate. That is equals to here 20 volts, 20 ohms, 5 ohms, 12 ohms, 16 ohms, 2 ohms. Here VAB is nothing but voltage across 16 ohms. VAB is nothing but voltage across 16 ohms. Now we need to calculate what is the voltage across 16 ohms. For that, let us go with the nodal method, because here if you go with mesh analysis, two meshes we need to go. If we go with nodal method, we can get with one node method. So let us consider the node voltage as V1. So KCL at node 1, KCL at node 1 is V1 minus 20 by 20 plus V1 minus 0 by 5 plus V1 minus 0 by 28, because 16 and 12 ohms are in series, which is equals to 0. So V1, if we take common, 1 by 20 plus 1 by 5 plus 1 by 28 is equals to 1. So V1 is equals to 3.508 volts. So now we got V1 as 3.508, and this V1 is divided into two parts, that is 16 across the 16 ohms and 12 ohms. These two are connected in series because no current is flowing through the 2 ohm resistance. So V16 ohms is equals to V1 into 16 by 16 plus 12, that is equals to 2 volts. Now we got VTH is equals to VAB is equals to V16, which is equals to 2 volts. Now we got the VTH value. And then we need to calculate the Thevenin resistance. For the Thevenin resistance, we need to make the voltage source as short circuit. So for that, I am making the voltage source as short circuit. Here is the 2 ohms, 20 ohms, 5 ohms, 12 ohms, 16 ohms, 12 ohms and 16 ohms. This is the REAB or RTH, where RTH is equals to, if you see this circuit, there are different more number of resistors are there, so we have to go with 2 or 3 steps to calculate the RTH. Now let us see from these two terminals, A and B terminals. So RAB, let us take, don't take AB, let us take these terminals as XY, because already we have taken AB terminals as the output terminals or load terminals. So RXY is equals to 12 ohms is in series with 20 is in parallel with 5, which is equals to 12 plus 20 into 5 by 20 plus 5. 12 plus 4, which is equals to 16 ohms. Now the circuit will be replaced with the 16 ohms, 2 ohms, 16 ohms, 16 ohms. Now these two 16 ohms are connected in parallel, that is in series with the 2 ohms. So RAB is equals to 2 ohms is connected in series with the 16 is in parallel with 16, that is equals to 2 plus 8, which is equals to 10 ohms. This is the RAB value, that is nothing but RAB is equals to RTH is equals to 10 ohms. Now we got VTH and RTH. So with this we can go with the calculation of load current. Now we need to calculate the Thevenin equivalent between A and B terminals. For that, when we need to open circuit the load resistance, that is 72 72 volts, 6 ohms, 3 ohms, 12 ohms, 4 ohms, A and B terminal. Here we need to calculate the VAB. For that, we need to calculate the voltage across 4 ohms and 3 ohms or 6 ohms and 12 ohms. So for that, 72 volts is connected in parallel to the series combinations of 6 ohms and 3 ohms and 12 ohms and 4 ohms. So let us calculate the current first, I1 and I2. So I1 is equals to 72 by 6 plus 3, which is equals to 72 by 9. So 8 amperes. In the same way, I2 is equals to 72 by 12 plus 4, 72 by 16, which is equals to 4 amperes. Now the current flowing through 3 ohms is 8 amperes. Current flowing through 4 ohms is 4 amperes. So VAB is nothing but this is plus minus plus minus plus minus. So VAB is equals to, so we got I1 and I2 values. After getting the I1 and I2, we need to go with the calculation of VAB. So for that, if we apply the KVL in this loop, if we apply the KVL in this loop, that is minus V3 plus VAB plus V4 ohms, which is equals to 0. So VAB is equals to V3 minus V4. So V3 is 3 into 8 minus 4 into 4, which is equals to 8 3 is 24 minus 16, that is equals to 8 volts. VAB is nothing but VTH, which we got it as 8 volts. Now we got the VTH and then we need to calculate the RTH. So for calculating RTH, we need to make the voltage source as short circuit. So for that, I'm making the voltage source as short circuit and I'm going to redraw the circuit. It is going to be short circuited. Now the resistance is 6 ohms, 12 ohms, 3 ohms, 4 ohms. 6 ohms, 12 ohms, 3 ohms and 4 ohms. This is A and B terminals. So here, in order to get the equivalent resistance, we need to replace the terminals, that is AB terminals as out and the short circuited terminals into the inside. So here if we take the AB terminal, A terminal out, 6 ohms and 3 ohms. 6 ohms and 3 ohms, and here it is short circuited. Twelve ohms and 4 ohms. So this is REAB. So REAB is equals to RTH is equals to, here 6 is in parallel with 3 plus 12 is in parallel with 4, which is equals to 6 into 3 by 6 plus 3 plus 12 into 4 by 12 plus 4, which is equals to 18 by 9 plus 48 by 16, which is equals to 2 plus 3, which is 5 ohms. This is our RTH value. Now we got the VTH and RTH, then we can calculate the load current. In this session, we have discussed some of the examples and different models for Thevenin's theorem problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.